Yeah, we have enough chairs, I think. Thank you for this. Thanks, that's way to help us putting chair together. Okay, so, oh, there are some questions. Gregory, go ahead.
Yeah, this was a fantastic session. I'm sitting over there, I'm really impressed with everything you've done. I had tons and tons of questions, but I resisted except once. Now, in our community, we love to publish papers, right? And the wonderful feeling we have when a paper gets accepted. Great. We have a tradition of doing distinguished papers where we take a little more time, a year later, to assess something. But I want to ask you all the following question about your work. What about your work is going to be important for people to know about 5 years from now?
Okay, who wants to get started?
So one of the things that should be inspiring from the work that we did is to be bold to explore new kind of sensors. And I think that is one takeaway that I would like everyone to take away from our work, that there is a way to look at problems that have existed for a significant amount of time and still introduce some new kind of sensors to change how we look at those problems. That's about it.
I totally agree with Ashutosh, actually. And we actually predict a huge impact. I mean, we actually believe this is not just for learning a new way of sensing. We believe our paper can be actually applied and it can become a commercial product. That's why we actually have filed a patent about it. So that's my two cents about it. Anyone else?
Okay, so I'm the last one with this thing on the front chest. So I think I believe there was a kind of little awareness, little work in HCI community around this this part of the body in general. And actually, when you combine it with arts and self-expression, our work could be a foundation for many, many applications, especially in self-expressions when you combine it with the design. This is how I look at it now. This is a niche part of, let's say, hardware and software area that could be explored, but still it has so far limited attention, and now I think we are giving the foundations to more work to appear in the future.
Yeah, I hope this work can explore some new interesting applications and to explore more, to combine the millimeter wave signals, to combine with other existing modalities, just like we do use the radio signal to transform the radio signal to the audio signal, to explore some privacy and security problem and human interaction problems, to give some inspection for these directions. Yeah, thank you.
I presented the work for on-skin prototyping toolkit. So our lab has been putting continuous effort in developing different tools, because like on-skin interface is an emergent field. It's a relatively new field in the wearable computing, and then we think if we can continue developing new tools for it, we can democratize this field, on-skin interface, and maybe in the future, more and more people will get involved in this field. And our ultimate goal is to create the type of on-skin interface that can be adaptive to wear on different body parts, and then people can integrate functions they want, they need. So it'll be a huge contribution if we can keep continuous this.
Yeah, for me, I think the most important for sensing, first I think is the vibration of sensing, because when users integrate with different, sensing technologies, the hand, maybe the bodies can introduce a lot of noises. So maybe like in our Hippo prototype, maybe we can introduce the vibration sensor and to make our technology more stable. for me, the most important thing maybe in the next years, maybe the smart ring technology, because this year's the smartphones, I mean the smartwatches and the next smart technology already developed, but the ring technologies seems haven't been explored too much. I noticed some industrial production about smart ring, but very few functions. Maybe, but because the smart ring is very small, very easy to carry, and it's better for our community, the mobile and pervasive computing. So maybe in the small ring, we can embed a lot of sensors, like the light sensors or vibration sensors, or air sensors, or different sensors for, I mean, to detect different conditions. So for me, I think ring is very important in the future development.
All right, yeah, Christine Liu, University of Colorado Boulder. Thank you all for a very interesting work and a very nice presentations. I want to ask a question, because generally for all of us working with the sensing, like when we do experiments, like we try to get participants and then try to, design the experiment in a way it's representative of the intended use case, but we cannot, of course, like always get to the real like users or in the real environment. So maybe if you can maybe I think all of you can probably comment on like what was like say, if we say one scenario that say you couldn't test and you think maybe particularly challenging if you are doing that in a real world setting with a real world user. Thank you.
Start.
This is not very much related to what I shown, but I mentioned about this device for measuring and detecting people that are breaking their social distance. That was work done during the pandemic, and this was really challenging to test with users, especially when still, the limitations were on. But still, it seems so right to do the experiments, and it couldn't be, theoretically, simulatingly tested. It should be, with real people. So we did a lot of, informal work to do it, and it's really the satisfaction that you have out after the experiment that it's really pumping your for next several years, especially for young people that have achieved something for the very first time in the very difficult conditions. It's really worth to sometimes even maybe push the barriers and go around the limits, and it's worth it.
So I completely agree with what you're saying. It is very difficult to get specific populations that would actually benefit from what we do. I think there are two answers what I want to say about it. One is maybe our job is to show the feasibility, and then hopefully showcase that feasibility to the right people so that they take it forward. We can never match the scale that would really be needed to take this out in the wild, and maybe that is somebody else's job. But the other aspect is particularly about this body signals. It turns out that every individual who actually is involved in giving out body signals own their own uniform, have their own hard hat, have their own gloves. In which case, very different from usual use cases, you literally need only one person to test whether that thing works on that person or not. We don't actually get opportunities like that enough. But if you think about it, is it really needed to be scalable? Or is it okay to just be useful for that one person, and then the model is generic enough that every person could train their own uniform? Right, so that was, when we thought of this and when we actually discovered that really in these use cases, it's perfectly fine to not have 200 participants. It was actually a relieving part of the paper.
I would also like to add some points to about the scalability. So I think it is essentially important to have the system distribute to a wider range of users. But then what we want to do is also like providing prototyping tools so that designers can use it to like test the prototype and experiment with different designs. So then eventually we are distributing these tools to the designers, not directly to the users. And then later the designers can develop the tools that might be suitable for a wider range of the users.
Yes, thank you for your question. This is also what I think of, because when I did the experiment, it's hard to recruit all the population include all the ages from small children to elderly, especially to recruit some participants maybe with the real health problems. Because in this way, we needed to have the approval of maybe the hospital or the institute or the ISWC institute, so it's hard to recruit, all the varieties. So I think the work for us now is just a proof of concept. We have this kind of work, so published, so we can show this work maybe to the government, maybe to the hospitals, and then we can collaborate with them to make it in a real product.
I totally agree. It's really hard to find participants and going through all these IRB processes and all that stuff. It's really hard, but there's one thing I really want to emphasize. I believe it is also really important to have a lot of people, as many people as we can add, because only that way we can have more inclusive systems. Years ago, from my personal experience, we are in a male-dominated area, and my participants were mostly male. But I have realized actually the vital sensor data I have been collecting was totally different in female participants. So it is definitely important to have divergence and as many people as we can, so we can have more inclusive systems. That's my thoughts.
Yeah, the data collection is quite difficult, especially it involves humans. It may need to have the review from the university. So in our design, we mainly in this work we mainly collect the data from the loudspeaker, and in our work we were conducting is also involves collect data from the human. It is quite difficult. So we may need design some recruiting plans to attract more participants to involve the experiments. So to give some groupers just like that to attract more participants. Yeah.
I do have a question for you, actually, following same lines, because one thing differentiates UbiComp from other communities, UbiComp care about real-world application, real-world deployment. And then I believe on all your papers, you talk about like a scenario where your solution gonna work. But then at this moment, it's a research prototype, right? So there's a gap from research prototype to real-world deployment. So, and there are challenges to be addressed. Can you talk a little bit more, what are the challenges you think need to be addressed before a system can be deployed? And then what are the challenges, usually there are two categories, I think. One is it's fundamental limited. In 50 years, you cannot see a solution. Others, you can see it can be solved by time machine. For example, 50 years later, like battery will be a less issue, right? So can you talk about first, what are the challenges you need to address to be deployed large scale in the future? And if there are challenges, do you think that can be solved somehow in the next couple of years? Let's start.
I think that's a great question. So because Aula has been doing prototypes, research prototypes for always, and then we always found the participant feedback like practical issues, reliability issues. For example, is your device waterproof? And what if the device fall off during the daily activities, things like that. And I think for our case, if we don't think about the power, like the battery issue, most of the case, the device can be improved easily if we add the waterproof layer, and also we improve the insulation between the circuitry. So for our case, I think most of the issues are like minor. If we really want to deploy the prototype into a real product, it can be done easily if we collaborate with the manufacturer. Yeah, but at the same time, we also feel like, for example, how to make a robust circuit connection, how to ensure stable like power supply. Those are like key limitations for the current wearable computers.
Yes, this is a very realistic question. Yeah. For my research, the sensor size is quite a challenge because we use off-the-shelf reader, but it has a fixed size when for the product when we get it. So if we want to make it in the practical experiment environment, we need to customize the radar size and other sensor size to make it suitable for our useful to make it useful. Yes, this is the first challenge, and the second challenge I think is about the data amount. So most of us need to train a deep learning model to make it work. But for data collection, it is quite difficult. One is for the data amount, and the other is for the data diversity. So yeah, we may need to large data set, just like the large language model or large vision language model, etc. So we need more data to make it more reliable. Thank you.
I think it's an excellent question. I think going forward into the real world is actually important. In the work that we did, it's interesting that we can always stage it slowly. We can actually have gradual improvements. So we could, for example, start with the sports application, which is not a safety-related application, right? And some errors are tolerable, and we understand and we learn from a real-world deployment. Once we have enough confidence on the system and we have looked at other practical issues, including waterproofing, for example, how does it work for a 4-hour game, or things like that, then we can move to new applications, different applications like aircraft marshalling and law enforcement and so on. So I think a gradual approach is probably the right way for us to go.
I can say that I see no obstacles. It's just a question of money. So you either need to convince someone to risk his own money, or use some other way to get the money if you are if you are a believer in what you are doing. That's it.
All right. Okay. So I think for the interest of time, we have to conclude this session for now. Let's raise the last round of applause to our speakers. Thank you. All right. So before you leave, there are posters there. Feel free to talk to the authors and posters, and also stop by to all the speakers to ask them questions. Thank you.